And why is it so difficult to automate and orchestrate carrier networks when enterprises have been doing it successfully for years? What are the carriers' fears or issues with current solutions which are hindering greater deployment? Here in the Dell TI Now studio at TIA 2016 to tell us a lot more about that are Ian Hood. He's Global Technology Architect at Red Hat. Next to him is Sridhar Apakandu. He's Senior Manager of Product Line Management at NetScout. And on the end is Larry Horner. He's Chief Technology Officer and Solution Architect for Communication Service Providers at Intel. And gentlemen, welcome to the program.
Thanks.
Thank you.
Thanks for being here. I want to start off with you, Larry, talking about, or asking you about the difference between automating and orchestrating a carrier network and an enterprise network.
To begin with, the national infrastructure that is the carrier network is devilishly more complicated in many regards. We have throughput and latency issues that are time sensitive in a way that we don't see it in some of the cloud environments. We also have traceability, visibility, and manageability of the network issues that are in there, whether we're talking about lawful intercept requirements that are encumbered onto that network, or the interaction that these networks have with each other, the interconnect agreements that need to take place that drive the functional requirements into that network. So it's the complexity of those flows that exist inside that network, as well as the velocity and the variety of the vendors that have put these things together.
Yeah. So just adding on to that, when we talk about service providers, right, we're talking about orchestrating a service. And a service typically can span across multiple domains, so you can have a service starting all the way from your RAN, going to your EPC, and going all the way into your maybe IMS. So when we talk about different domains, that's where the challenge comes in terms of orchestrating, because each one could have a different orchestrator, could have a different set of VNF vendors. I know, Ian, you don't like to use the word orchestrator of orchestrators, so I'm going to just change it a little bit and say maybe a Uber orchestrator that basically orchestrates.
I'm actually going to probably name it for you. It's probably an automator of modernized business applications.
There we go.
Okay, so we have a new way to kind of think about it.
Yeah, we'll get a name out there. So I think that's where the complexity comes, right? You have to orchestrate from all the way from your RAN all the way to your data center, and you don't have the tools right now that can do it all the way end to end.
And to kind of follow up on what Larry was talking about, in terms of these domains, it's they have multiple customers as a default. Right? The enterprise is their customer, along with us as consumers, and they've got to secure that, be able to bill for it, and make sure that that data is protected between those businesses as they attempt to automate that business for themselves and on behalf of an enterprise who's saying, I'd like a service in which you automate that for me. So he's actually kind of got to do a double job when you think about it.
And we made a lot of progress. The first step in the network function virtualization really was the work functions themselves. And while it continues to be a journey, we made a tremendous amount of progress, but that work needed to be done. We needed to vet out and prove that that was actually going to be functional, and that decoupling of the hardware and the software from the purpose-built solutions into this more open environment that we have, and we can now cloudify. The next step onto that then would be the management, the creation, the configuration, the deployment, which is where we get into the orchestration, the mano, if you will, of these platforms. So it's the next step in the journey. And where we are today in that is, I think a colleague of mine once called it the zoo of orchestrators a year ago or so. We're no longer at that point now. We're having a crisper picture. Maybe it more looks like Picasso's Three Musicians. There are pieces there. We can pick it out. We can identify it. It's not a final image yet. The picture is not completely congealed into its final view. But we know where we are and we know where we're going. And as I say, it's a devilishly complicated problem when you look at it globally from an economics perspective, from a vendor's perspective, and just from the sequence in which you need to logically break this problem down and attack it.
Right. And if you take a look at the other part of the operator is that just by the nature of the scope and scale of what they do, it's not a single vendor question for them. It's mandatory, it's multi-vendor, and they have to be integrated between these things, and that's why we need to kind of build that collaboration amongst our community of vendors, operators, and we've now got the open source communities that are helping us innovate faster to solve some of these problems in a way that's economical for our
clearly
operator.
The first step was the vendors themselves who were providing those work functions that I spoke of were using their legacy management systems, their element management systems for their orchestration. If you look carefully at it, you go, well gee, that kind of looks and feels like what we did in the old world that were in EMSs. So that was that first generation. generation. And now we're getting to the second generation, to your point, Ian, is that through standards and through capturing well-described configurations of this is what the workload is from an operational perspective, this is what networking needs for that particular workload, and getting those configurations nailed down, agreed to. Now there can be variations. That doesn't mean that there's only one way to to bake the cookie. You can have different varieties of cookies in there, but we have a formula for it that says these are the ingredients that go into it. And now to drive that industry so that if you have an interesting workload in the network, IMS, I think I heard you mention, a very interesting workload. The large carriers typically are not going to have just one vendor solution into their network, but they'd like to have one orchestration in there. So as they begin to manage and operate that network, they've got a single location where they're managing vendor A and vendor B's solution for IMS, for operational issues, for integrity issues, and it also reduces their organizational OpEx in that we don't have to have as many staffs. We have a single organization responsible now for my IMS solution, where in the old days I would have had two, one for each of those vendors.
And then this is just not the different vendors on the VNF, but you also have different platforms itself, right? One of them could be based on OpenStack, something could be based on VMware, something could be based on Microsoft. So you've got to get all these things working together. Right. And I think that's where the challenge is.
And the other thing is it's not just the network services, because we've already been down the path for the application services that are being delivered out of the cloud. So now what we're doing is we're building a hybrid cloud platform for applications and now network services that I need to be able to orchestrate those resources and optimize them. It's really a distributed compute, network and storage optimization problem that we're solving to deliver any service we'd like out of a platform, and it's multi-vendor.
Right.
You've answered all my questions. No, I'm kidding. Thank you. Now, Larry, I wanted to ask you about, was service chaining part of your description earlier, or is that vastly different
I've not spoken about the service chaining yet, and sometimes I like to break these down into garden variety examples, if you will. And the trivial one to talk about here is if you look at a universal CPE or a virtualized CPE, customer premise equipment, where we're starting to put that functionality into the network itself, where we may have a routing functionality and a firewall functionality. And let's say that for whatever reason we choose to go with a particular vendor, and I'll pick on somebody, not to pick on them, but just for as a talking point. Let's say that we choose the vRouter from Brocade as our router of choice in this service offering, and for whatever reason we choose to go with a Checkpoint or Palo Alto for a firewall. And in that case, then these instances, these VNFs that are going to be spun up and running on this cloud infrastructure that we spoke of, will get created and instantiated through the orchestration, but it's not a service yet. It's not a service until the router and the firewall, those VNFs, actually interoperate and communicate, because that's what the customer wants in this CPE environment. They want that as a solution where we've got the routing capability and the firewall capability being offered into them. And now what happens is, if you think of it as a software problem, is that these two guys need to talk to each other. These applications need to communicate, and that's what service function chaining is. In the old world of purpose-built, what I would do is I would have two different boxes, and I would take a wire and I would plug the wires from box A to box B, and I would say, okay, here's your IP address and here's your IP address, and let the layer 2 routing take care of it. Now there may be other devices are in between, but you understand what the model is. Service function chaining says, I still need to do that same thing. Well, now these applications are virtual, and I want them to efficiently, without consuming excessive resources, and we could talk about what we mean by that, and there's lots of things, whether it's memory, CPU, packet loss, quality of service, latency, but we want those two services to efficiently communicate with each other, and it's that service chaining that is the mechanism for which those two services, potentially from different vendors now, that give you a single application, interoperate. And it's the orchestrator's problem to have a mechanism that when it spins that service up to say, oh, and here's how you two guys need to talk to each other. Here's the protocol that you're going to use, here are the interfaces that you're going to use, and this is how you're going to achieve that efficiency that I spoke of.
But if you sort of take that service chaining and say it really is just the intent that the operator wants to deliver as a service, and kind of what the customer does is he says, okay, I'm going to go to a portal, I'm going to go click and say I'd like this service, and that intent is I'd like this much routing, this much firewall, this much bandwidth, and he says click, just like you go to Amazon and buy something, and from that point on, that entire service intent is mapped not just to those virtual devices that are chained in the service, in the data center, wherever they might be, but it's actually going to connect up the physical and virtual topology to actually connect to that end customer who wants the service.
I typically think that more of that is the issue in this example I spoke of is the SD-WAN issue, where you've got a portal and you're going to be able to offer that up. To your point, it's all one service at the end of the day. The customer at the end of the day doesn't care how you do it; they want you to do it effectively and economically and efficiently.
Yeah, I think it's one thing is about managing the resources, but the other thing that you also need to look at is how these packets get routed between all these different elements, right? You need to look at the latencies. I mean, every service has a specific SLA, right? So you need to keep in mind that when we are routing packets across all these different elements, you need to maintain the latency and also still you need to get the right SLA too.
Ian, I thought you wanted to.
Well, I just did the other point I made it earlier today is that there's technologies out there right now that we're just kind of doing it in a static way at the moment. This chaining for the replacement of the wire between these elements, and we've got to make sure that we come up with a simple way that we do this and don't overcomplicate the way that we spin up this service and this topology and just make it more complicated for these different applications and network functions to talk to each other. So the standard that we're looking at that comes from the ITF, network service headers, yes, it's an interesting approach, but it may not be the end game.
May not be the end game. I would certainly agree with that. It's an interesting approach, and we have examples in the past where where standards get created in paper and no one actually ever compiles it. I don't know that we're at the point yet that everyone has decided that the ASH is the way that we're going to be performing our service function chaining. It's certainly one option though.
Yeah, I mean I know IATF has defined some standards out there, and we talked about it earlier too. I mean, I don't think there will be one standard that everybody can agree upon when it comes to service chaining.
Right. And it just applies to how the whole service model thing, we had that discussion this morning as well, that there's not going to be one standardized service model, one data model for this, because the service provider wants to differentiate his services, therefore he's going to customize his models and customize how he delivers the service. So we've got to come to something that's extensible that can then be automated and extended to whatever service you like.
This clearly is a struggle because it ultimately breaks the legacy network equipment provider's model, if you will, where now the a la carte choosing that you're talking about at the end of the day, so whether it's service function chaining or whether it's orchestration, really becomes best of breed and wide open. So it's a disruptive play potentially for the industry.
Sridhar, I want to finish with you, and I know you guys touched on this quite a bit in your sort of back and forth, but just for our audience, so they have a sort of a clear message from you, what is considered the state of the art of NFV orchestration and automation?
Well, in terms of orchestration, I think there is a proliferation of a lot of orchestration tools in the industry, both commercial as well as open source. The problem right now is when each VNF vendor comes in and they want to deploy their solution, they come with their own orchestrator. And that's what's delaying out the entire rollout, because when you go into the labs and you want to bring in another VNF, then you got to do this work of integrating with the existing orchestrator, and I think that's where I think the standards needs to be defined so that when somebody comes in, they can easily integrate with. Apart from that, I think there's a lot of work that's being done in the open source community, and I think that's where the industry is going towards. A lot of service providers are putting a lot of emphasis on the open source, like for example, we have OpenO that's coming from China Mobile, which has put in a lot of effort over there. And then we have OSM, which we talked about earlier this morning. And then also from an OpenStack perspective, we have the Tacker project that's going on. So I think a lot of service providers are putting emphasis on open source, and I think eventually that's where everybody is going to start moving towards. And I think that's what in yesterday's keynote speak, John Donovan mentioned the same thing. I mean, AT&T is embracing OpenStack to a large extent, and he even mentioned that the e-com platform that AT&T is building could eventually get into the open source community.
Yeah. And we're definitely getting much further ahead than the current competition that's deployed all over the place, which is a combination of fax machines, spreadsheets, lots of fingers, and that's really kind of the issue even with orchestration, is that a lot of it is still manual scripting that's not really standardized, and the languages are kind of different. In some cases, we force them to learn languages they don't know yet, and we've really got to make sure that when we think about it, orchestration is a good piece of the puzzle for both resources and services, but how do I automate the entire process of spinning up the service, doing upgrades, and taking information out of the network, taking up to analytics engine so I know what's going on so I can get the service assurance I need and the security and policy with those as well. So it's a bigger problem than just the orchestration puzzle.
It's clearly a journey, and we've got a number of steps that are ahead of us yet. So we're making good progress. We understand what the roadmap is, and it's going to be a few years before we get there, though.
It sounds like a complex road ahead, at least for NFV orchestration and automation for the carrier network. I appreciate all of you contributing. It was an interesting discussion. I didn't have to ask anything.
That's great. Well, thanks for your time today.
Thank you.
Thank you
Thanks,
very
Ed.
much.
Right,
Appreciate
thanks,
your
Ed.
time.